Hello, my name's Gordon. I'm building a Waiex. I'm building a Waiex with a Corvair motor, and I'm kind of doing it my way. I'm going to do a quick video to show some of the highlights of this build, some of the things that I'm doing that are different. If people are interested, I'll do follow-up videos maybe on each different system, something like this. So to start, we have our Corvair motor. This is a 3-liter motor, the 120 horsepower version. I've started working on the baffling. It's not finished yet. I can address all the different systems of this, but let's just say that the motor is a William Wynn built motor, and I expect excellent service out of it. The engine mount was built by SPA, the guys that build the Panther. They make parts for converting a Waiex or a Sonex, not the B model, just the A model, to use the Corvair motor. So this is their motor mount. And then I've used Tracy O'Brien's gear. I like the tapered steel gear better than the titanium gear, so I've gone with that. I've gone with Marci Brakes and 5x5 tires. So off the ground you can see they spin. It says 5x5. I've gone with hydraulic brakes. In fact, I've gone with dual independent hydraulic brakes. You can see the brake line running up the gear leg. Not sure if that's permanently how it's going to be fixed. In fact, I'm pretty sure I'll change this fitting to a 90 degree to bring it more in line with the gear leg. And I think also I'm going to replace that with a steel fitting instead of an aluminum fitting. It just seems more secure. If we take a look inside, this is my snake pit of surprises right here. This, of course, if you know the Sonex design, the plastic fuel tank goes in this area, with the fuel filler is here. And underneath the plastic fuel tank is all of my systems. So these black posts, these are what the rudders hinge on. If I move a rudder pedal, you can see that the opposite pedal moves. In fact, all 4 of them move, of course, because the rudders are hooked together. You can see there's a considerable amount of extra hydraulics in here. That's not part of the original Sonex design. That's my own personal design. My son and I designed these rudder pedals. I used the Matco master cylinders, and I've run, it's all AN3 hose that I've gotten from Holly Performance out in California. It's all Earls. All the hydraulic stuff and the fuel stuff is all Earls. Here you see the coils. This one has 1 set of spark plugs per cylinder, but it has 2 ignition systems that are completely independent except for the spark plugs. So these are the two coils, 1 for each ignition system. The system is split in the distributor. There's 1 set of points and 1 set of electronic ignition in there. I have a Matco parking brake here, which is plumbed into the between the pedals and the wheels. It just allows to hold pressure to hold the parking brake on. You can see the fuel system is more complicated than what you normally would expect in a Waiex. This is where the tank plugs in right here. And this is all AN8 half-inch tube. The reason for that is, well, several-fold, but what drove me to the half-inch is I'm going to have an aux tank in the back. And the aux tank is going to be filled just from the main tank. So on the ground only, you can fill the main tank. The aux tank is about the same size. You can open the valve with the AN8 half-inch plumbing. The aux tank should fill fairly quickly. In fact, I've timed it and it's something like 5 minutes. Also, I wanted a fuel pump. I'm concerned about, people seem to have a lot of vapor pressure problems, which I think is largely due to the fact that there's not very much vertical distance between the outflow of the tank and the inflow of the carburetor. So I've incorporated a fuel pump. It's a fairly large one, which I'm going to run on a controller, so it'll be reduced speed normally. There's an override mode, so if the controller fails, you can go to full power. There's also, even more importantly, there's a very light one-way valve here, which I got from Andair. And there's the regular plumbing that would be the gravity feed system, runs through that one-way check valve and straight to the carburetor. So that the original system is still there, with a bypass of this extra pump. Also, when you're using the auxiliary tank, it will feed into this kind of manifold, fuel manifold here, also through a one-way check valve from a pump that's by the tank. And it can supply fuel directly to the engine. There's a return line that will go back to the tank. So as it's supplying fuel to the engine, any extra fuel that it pumps will go into the main tank. The last change I made with the fuel system is the vent. The vent from the main tank will go internally all downhill to the aux tank, and the aux tank will be vented to the atmosphere. So any overflow from the main tank just goes back into the aux tank. This allows you, for example, to run the aux tank when the main tank is completely full. You can run the aux tank, fuel will circulate, it'll go to the motor, extra fuel will go to the main tank, and overflow from the main tank will go back to the aux tank and be pumped again. Extra pumping, but pumping fuel doesn't hurt anything. So that's my fuel system layout real quick. The next thing that we come to, obviously, is you can see there's a considerable amount of wiring here. I'm going with a single alternator and a 2 battery system. This is because of the kind of flying that I want to do and the places that I want to go. I want to have a dual battery system, so that I've incorporated that in here. If the photographer can step to the back here a little bit, you can see my mock-up of the instrument panel. This is just a mock-up, and I've already changed how I'm going to lay things out, but you can see it's a G3X, it's a G5. I'm going to use the GNX 375, and I'm going to have a couple of regular old-fashioned instruments, particularly oil pressure and volts. I think those are two that it's very important to know the actual answers. Below that, though, you can see the switch panel. The switch panel is really the heart of my electric system. The switches are all 3-way switches, off in the center. So at the end of the flight, all switches should be centered. That seems simple enough. And typically up is the normal function and down is the alternate function. This allows me to do things like have one switch for the fuel pumps, which precludes you having both fuel pumps on at the same time, because one is up and one is down. That's just as an example. The other part of my electrical system, which you can't quite see yet, is another switch panel. This one's my emergency switch panel. This switch panel gets powered directly from the batteries through fuses at the batteries and just an 18 gauge wire, so up to 10 amps. And these are mostly light duty items, but critical to flight. Things that if you shut off the master, you still want. So, for example, they're labeled from the back. You can select which battery is going to power the emergency panel. It has the emergency power system for the number 2 ignition. So if, for example, in flight, if you switch this switch, you switch from number 1 to number 2 ignition. You switch from the main electrical system to number 2 battery directly. And it gives you an ability to very quickly retain engine operation if there's a problem with that, or to keep the engine operating in the event that something catastrophic is happening, a fire, for example, where you need to turn off the master switch immediately. You can turn this switch on, maybe 1 or 2 others for other devices that you definitely need to have. And then you can turn the master off and continue the flight. Also, because this panel is powered directly from the batteries, only through a fuse, not through a master contactor, you also get rid of that 1 amp draw of the master contactor. So another situation would be if you need an endurance situation. For example, you're far from airports and you need to have power for an extended period of time and you lose your alternator. you can turn the master switch off. You can turn this switch on to keep the engine running. You can select a couple of other items, and you have now extremely low draw, like maybe 2.5 amps, to keep what you need running to continue the flight. At 2.5 amps with 2 different batteries, you should be able to continue the flight longer than you have fuel. And this thing has a lot of fuel, so that should be a long time. Looking also behind the panel, you can see I've done most of the cabling for the avionics. This one, for example, is for the comm nav radio, which I'm going to use the MGL system for that. So it'll be a Razor in the panel, and then the other 2 remotely mounted. Moving over, I've got fuses. This block is for the avionics. This block back here is the main fuse panel. And all of the avionics, for example, are fused off of the main panel, and there's an avionics switch, so you can deselect the avionics. But I'm comfortable doing that because even in a failure over there, you still have a backup for the things that you really need with this panel here. And I like the idea of being able to have the avionics off when you're doing the engine start, or when you're operating on the ground. Maybe you don't need the draw of the avionics. It depends on what kind of mission you're going to do. All the grounds are to here from throughout the airplane. There's a large forest of grounds. And then behind here you can see there's 4 relays to handle the heavy duty items, so that those loads aren't through switches, they're through these relays. I like the idea of having the switches in the panel, and I realize that the wiring runs aren't significantly shortened, but using these relays takes the load off the switch, which I think is important. This is the PWM controller for the fuel pump. It has a knob on it so you can vary the speed of the pump, but I'm not planning to make that flight accessible. Here's the second panel. This is just minor switches. It'll be over on the far side of the instrument panel. Seat heat switches, cockpit instrument, rheostat, and push buttons for a couple of items. That pretty much sums up the electrical system. As you know, the generator for this engine is about a 20 amp generator, and I've calculated the normal loads will be around 10. If you have the seat heats on in the winter, you might get up to 12, 13 amps, but well below the 20. There's almost no situation where you actually approach the 20 amps, and with everything on the airplane you can have on, it's still something less than 20 amps. Obviously, when you're on the ground with this, this is a direct drive permanent magnet generator, so on the ground you don't get very much power out of that. So on the ground you'll probably be running on the batteries. You need to limit the load. I think at around 1200, 1300 amps, RPM, you'll switch over and the alternator will actually be able to power the loads. So maybe one answer, if you're going to be on the ground for an extended period of time, you can just have to run the RPM a little bit higher. Okay, looking back, I have the seat installed right now. This is, all the Waiexes are dual control. So I have the 2 sticks. Since the seat's installed, you can't see underneath the seat, but I put the remote boxes. The ADARS is under the seat. The autopilot pitch servo is under the seat. The comm and nav radios are under the seat. Also, I've made some boxes. My Waiex is going to be unique in that it's going to have electric trim for pitch, yaw, and roll. The roll is easy because that's just an aileron. There's going to be a tab on the aileron. For the pitch, that's more complicated. With the Y tail, as you know, okay, so they both move up and down just like the elevator on a straight tail, but they don't move. They're not connected together, or they're not directly connected. So when you pitch them up, you have to pitch both of them up, and if you then put in some yaw, one will go up a little bit more and one will go down a little bit. This needs to be taken into account with trim, because with trim, your trim tabs have to move both surfaces, hopefully an equal amount. So I overcame this by building a relay box. It's fairly simple. I can provide the wiring diagram for that box, but it essentially, if you use pitch trim, it commands both pitch servos both trim servos to move at the same the same direction, and they're the same kind of servo, so the rate will be approximately the same. If you command yaw, yaw takes authority from the pitch system, but it through a relay, and then it moves each servo in a different direction, which gives you the yaw. We'll see how effective it is, how necessary it is. Probably not, but in order to do the pitch trim, I needed to do the yaw as well. These servos are back here. We're going to take a sort of a tour around and get back to those. I guess the last thing, I'm going to step over here and look this way. Is I've gone with electric flaps, and you can see the flap actuator down against the side of the cabin. Down there. It's electric. It's a servo that also has a feedback mechanism, so that'll feed to the EFIS for the position of the flaps. Some of this wiring is hanging out. For example, this is wiring for the ELT. There's no way to incorporate it into the airframe until I actually have the ELT, but just from downloading the wiring diagrams for the ELT, this is the wiring I need. So moving back, nothing significant there. Oh, here you can see the fuel lines for filling and for using the aux tank. They just run back through the cockpit. In order to protect them and keep things steady, I built these armrests. I haven't installed it yet, but the vent line will be running under that armrest on that side. These are just a simple aluminum angle with a nice piece of wood on the top. So I think they add a little bit of class. They actually are in about the right place as an armrest, and also protection for the plumbing. On a later video, maybe I'll take the seat out and show all those boxes I built under there. Moving back, I installed the nav antenna inside the fuselage. I wanted it to be kind of below the tail. Nav antennas don't need to look up, and I wanted the tail to kind of protect it somewhat. In retrospect, it could have been back a little bit further and been more effective, but it's pretty good. It's close to the edge of the tail, so it should be protected. And here's our servos for the pitch trim tabs. They're installed under the fairing, which I haven't made yet. And looking towards the back, you can see the trim tabs themselves. And they're just actuated by this long cable. They actually work. They seem like they should work quite well. I sized them approximately the size of a little bit smaller, I think, size than the single trim tab that you would find on a Sonex if you did the manual trim. But since there's two of them, one on each surface, it seems like a rough calculation would be that they should be half the size. I think they're a little bit more bigger than that. I put my static ports here. I realized this location may have to change. This was just a guess. I don't have any data to support this exact location, but we'll see how that works, and it's not so hard to move a static port. That pretty much concludes my tour. I bought a lot of stuff from Peter Anson, and one of the things I have is complete tail wheel setup. I bought the fixture that goes in the fuselage, which is much improved. He had cracking problems with his original one, and he redesigned it to actually have a flexible joint in this fitting. It's the original titanium tail rod, and then it's his Peter Anson's tail wheel bracket, tail wheel, and you can just see the push rod sticking out on the other side there. If you see something that's not safety wired or otherwise pinned, don't worry about it. Obviously, I have several times more to go through the control system before the first flight. So this pretty much concludes my tour. I'd like to share a bit of wisdom from William Wynn. This is my thought for the day. And I hope you guys are all having a good build. Just build on and fly soon. That's my plan. Bye.